Now I'll look at a word problem that involves a linear relationship that we can put in slope point form. So if we look at this, a temperature in degrees Celsius C is a linear function of the temperature in degrees Fahrenheit F. The boiling point of water is 100 degrees Celsius and 212 degrees Fahrenheit. The freezing point of water is 0 degrees Celsius and 32 degrees Fahrenheit. Now, since there really isn't a dependent or independent variable here, either of these could be represented as the independent or the dependent, I will refer to degrees Celsius as my x values and degree Fahrenheit as my y values. So if I look at the boiling point, I have a coordinate here, 100 degrees Celsius for my x and 212 for my y value. And then I have another point, which is the freezing point, which is 0 degrees Celsius for my x and 32 degrees Fahrenheit for my y. Now, if we're writing this linear function in slope point form, the equation is this. It's y minus y1 equals m, the slope, x minus x1 in brackets. So we're looking for both the slope and we need one point. And we can use either of these points for this equation. So we need to find the slope first, and we can find that using the slope equation, which is y2 subtract y1 divided by x2 subtract x1. So if I look at these 2 points, if I call this x1 and this y1, and this second point x2 and y2, then I can substitute this information into this slope formula to find the slope. And the slope will be this, 32 subtract 212 for the change in my y's, and 0 subtract 100 for the change in my x. And when I subtract these, I get negative 180 divided by negative 100. And this fraction can be simplified to a positive 9/5 since it's a negative divide a negative. You could also write this as a decimal, which would be 1/8. As long as this isn't a long repeating decimal that you have to round, then you could leave it as this instead of using the fraction. The other thing we need is a point. So the point I'm going to use, since we're looking at x1, y1, I could use these, but I'll use this. I'll use this x1 and y1 that I've already found. Now I'll just remind you that I have called my y, or I'm supposed to use this since I called f my y values, I should be replacing y with f. So this equation is going to be the degrees Fahrenheit minus 212 is equal to the slope, which is 9/5, or if you wanted, you could use 1/8 here. And then since x is really Celsius, I'll call it C subtract 100, since this is the same value, or the x value in this point. So this is what my equation would look like. And now when I go to solve this part B, use the equation to determine the temperature in degrees Celsius at which iron melts. Since I'm giving a measurement in Fahrenheit, that will be replaced in my equation here with F. So I'm going to write my equation out. And what I'm going to do is replace the Fahrenheit with 2,795. Now, when I do this, the first thing that I'm going to do is I'm going to subtract these numbers. And when I do, I get 2,583 equals, and to simplify this a little bit, I'm going to divide this so that it's 1/8, C minus 100. Now, if you already wrote the equation like that, you'd be saving some time. So, now that I have this, what I'm going to do, Since this C is being subtracted by 100 or is having 100 subtracted from it in brackets and also being multiplied by this 1.8, since we're doing reverse BEDMAS, I need to divide this first before I start going into the brackets. So I'm going to divide both sides of this equation by 1.8. Now, when I do that, on this left side, I'm going to have 1435, or 1,435 is equal to C subtract 100. Now, the last thing I need to do to isolate this, since this is the only thing left on this side, I do not need the brackets anymore. So I can just write this right side without the brackets, because 1.8 divide 1.8 is 1. And then what I'll do is I'll add 100 to both sides of this equation. And in so doing, I get that the degrees Celsius is 1,535 degrees Celsius when that iron melts, which is the same thing as 2,795 degrees Fahrenheit.